In this video, we're going to look at example 2, where we identify the least common multiple of polynomials, and this will help us finding the LCM for when we need to add fractions that have unlike denominators. So the first thing, the question is, how can you find the least common multiple, or the LCM, of polynomials? And in part A, we're given x plus 2 squared, that whole quantity squared, and x squared plus 5x plus 6. The first thing we need to do is we need to factor each polynomial. Right, so what we're going to do is, let's take x plus 2 squared, and that's a pretty easy one. That just becomes x plus 2 times x plus 2. All right, and then my second polynomial, we have x squared plus 5x plus 6. And if you remember the factor sum chart, or how to solve this, again, I'm not going to go into crazy detail of factoring because this is more about LCM, but this would wind up being, x in each quantity. We need factors of 6 that add up to 5, so that would be 2 and 3. The next thing we need to look at is the LCM is a product of our, think of it as our factors. So if we have duplicate factors, that might come into play, but what we need to do is we need to look at all the factors, and I'm going to do some highlighting here to hopefully help us keep track here. So what I want to look at is I have an x plus 2 here, and I also have an x plus 2 here. We're going to treat those, in this case, separately for now. In the second group, I have another x plus 2, and I have an x plus 3. Didn't mean to erase that. I wanted to highlight that. So I have an x plus 3. So my actual LCM is a list, basically listing all of these factors. Each color, all right, think of them as highlighting, think of them as colors. So the x plus 2 was repeated twice in this first one here. All right, and it's accounted for once here, and that's why I highlighted each one of those in orange. That'll kind of be one of the things you have to get used to, but don't be too stressed out about it. So I'm going to take that first x plus 2, and I'm going to write every factor that is in either polynomial. And let's color code these. So I have these 3 factors, and the reason I only wrote x plus 2, this one in orange once, is because it's a shared one. Right? Anything shared, you only have to write that one time. But this second x plus 2 only appears a second time in this polynomial, so that's why we need to show it that second time. I know that might sound tricky, but hopefully after you see a and b both solved here or simplified or worked with, you'll understand that a bit more. So my LCM is x plus 2 times x plus 2 times x plus 3, or we can write that as x plus 2 squared times x plus 3. What's going to happen is in these problems, as you're getting used to these, as you get better at them with more practice, you're going to see that sometimes it is going to be better to leave it in this form, and other times you might want to work with the form where we've kind of combined those like polynomials and raise them to that power, in this case of 2. But it will take some practice to figure out which one is going to be more useful. So let's take a look at part B. We're going to do the same thing. To find the LCM, we want to factor each polynomial. So this first term, we have x cubed minus 9x. So I would factor out an x first. That would leave me x squared minus 9. And x squared minus 9 is the difference of 2 squares. So that can then be factored again into x plus 3 times x minus 3. So that's my first one. My second polynomial, x squared minus 2x minus 15. This would be our factor sum chart. So we're looking for factors of negative 15 that add up to negative 2. It would be x and x, and then factors of negative 15, negative 5, and positive 3. Again, I might be going through that a little quickly, but there are videos on factoring you could go back to for those. And then finally, we have x squared minus 5x. We'll factor out an x, and that's going to be left with x minus 5. So what I'll do from here is I'm going to kind of go back to my highlighting. All right, so let's start with that. My first polynomial, I have x as a factor. That doesn't appear at all in the second polynomial, but I have an x here as well. Then I have x plus 3. I have an x plus 3 here. I have x minus 3. That doesn't appear anywhere else. And then finally, I have an x minus 5 that appears in each of those parts. So it looks like I have 4 different factors I'm going to have to count for. The x plus 3, x minus 3, and x minus 5. So when I'm writing my LCM, I want to write every one of these factors. So I'll start with that x, and then I can just go in order as they appear. X plus 3, x minus 3, and x minus 5. So let's color code this. I want to make sure that everything has been accounted for. All of my colors are brought down. Now when you're writing by hand, you might not have access to all these highlighting colors, but you can use things like, little squiggly lines or dotted lines, double underlines, anything like that that might help you keep track and keep organized. So this would be our LCM, and each original of the polynomials goes into that LCM. So if you're really looking at it, this expression here would divide into that. It would be a factor of that. We don't need to worry too much about that, but it is something to keep in mind. I know this might seem a little kind of weird or annoying. Sometimes it's tedious when you have multiple polynomials and a lot of factoring involved, but really you're just looking for all of the pieces of all of the parts. Okay, so factor each polynomial that you're given, and this will come true. So if you looking ahead, example 3, we're going to be asked to add these up, and clearly they have different denominators. So to add these up, we're going to need to find a common denominator, and to do that, you'll use the LCM. Okay, so try it too. You have A and B, factor them, highlight, mark up whatever you need to do, and just make sure that each piece is accounted for.